Hi guys, today I would like to talk you about equation in a few forms, and I would like to end the set of slides of this video discussing about at least introducing the concept of uh, differential equation. Okay, so the important things is that it will be differential, meaning that it will involve, as we will see, uh, derivatives, and the other bit is equation. Means that, as I will show you in a sec, that we have something that we want to find out, and this something is related to something else that we know of. Differential equations are basically ubiquitous in math and in physics, and we will see that basically maybe in some videos later we will see that I mean, yeah, all of physics is based on differential equations in one way or another. So I think it's pretty important to have an idea of what they are. So let's start with the easiest case that I can think of, which is this simple equation: x, let's say 1 plus x is equal to 0. Okay, I know this is very elementary, but I think it's good to start from the basic. So the two things important to remember about an equation are the two sides of the equation. So one side, usually we tend to put the coordinate, the x, so the things that we don't know. We want to find out x in the equation on one side, and then we have something known on the other side. In this case is a 0, so a value. And then the very important thing is the equal sign, which means that these two things meant to be the same. So when we will speak about physics, for example, these two sides will have also dimension, like meters, grams, kilograms, joules, or whatever, and you need to check that both sides have the same dimension. Otherwise, you are comparing apple to pears, for example, and it's not good. I mean, you can if you like, but then it's not math or physics. In this case, we are dealing with just numbers. So the thing that you need to remember is whatever happens into this side here must happen in the other side as well. Otherwise, the equation drops out and it's not an equation anymore. So if the left side is smiling, the right side is smiling. If it's not smiling, this guy is not smiling as well. Okay. Now these smiley faces will be transformed into operation. So usually you have plus, minus, the division and the multiplication, and you do the same here. Of course, you can take other like square root, logarithm, exponentiation, if you like. I don't know, you name it, whatever you like. I mean, you can be creative within the rule, and sometimes even you can break the boundaries. I mean, anyway, so what I'm saying is that keep in mind that the equation sign is whatever is on the left side must be the same on the other side. So let's then try to solve this very elementary equation. I will do it in the pedantic way to begin with, and then later on we will get used to it, so we will not bother. So we want to find x. How do we find x? So we want to know x is equal to what? So one thing is how do we isolate x? For example, we can subtract 1. Let me put it here. We can subtract 1 on the left side, okay, and then we subtract 1 on the left side, you see. So the thing doesn't change because we change one side by the same amount that we change the other side. The good thing in this case is that we then carry on with the operation, and then we get that minus 1 plus 1 is 0, and 0 plus minus 1 is minus 1. Then we can cancel out the 0 because it doesn't add up anything, and we have x equal to minus 1. Is it true that x, is it true? Let's check. X plus 1 equal to 0. If we replace x by the solution, which is this one, minus 1, we do minus 1 plus 1, and guess what? Is 0. So 0 equal to 0, which is correct, right? We know that 0 is equal to 0. Okay, so as you see, this is a very simple equation. We can go more complicated than that, and I will show you in a sec. Things can go nasty pretty quickly, but I don't want to go in too much detail. Just follow the ideas, because I want to get to the differential part, which I think is more interesting. Okay, but let's do another example. Add a couple of examples, I don't know how many. So suppose we have x squared plus 1 now is equal to 0. Okay, and then we will do with the minus 1. Actually, let's do first with the minus 1 and then with the plus 1, because we can, to be honest. Now there are few ways I will show you a few ways how to tackle this one. Let's do the easy one first, or at least I don't know if it's easier or not, it depends, but let's do one first and then the other. Okay, so same trick as before. Square, we add 1 on the left side, and then we add 1 on the right side. Okay, good. Now we have x squared on the left side and 1 on the right side. Okay, now this is because plus 1 and minus 1 cancel out, and plus 1 plus 0 is 1. X squared is equal to 1, but we need to find x. We want to find x, not x squared. So how do we go from x squared to x? I don't know if you remember, but we can basically refresh it. There is a square root function that says that if you take the square of anything, you get plus or minus x. Okay, meaning that if you do the reverse, and you pick, usually you have to pick one. Okay, in this case we get the one side, but anyway, so because then you do minus times minus x is equal to x squared, or x times x is equal to x squared as well. So both of them are solution. Okay, so in this case the solution are 2, and the solution are plus 1 and minus 1. Okay, remember that I took the square root here, and then I took the square root here as well. Okay, so the square root of whatever this is, yeah. But anyway, so the other way to solve this one is to use a relation that I think we already encountered, but I will refresh it here. Suppose you have a plus b, and then you have a minus b. What do you get? You get a squared minus b squared plus ab minus ba. Now these are numbers, a and b, so a times c and b times a are the same value, so they cancel out because there is a sign that is different, and we get a squared plus b squared. Now, does it look like something that we see in this side here? Yes, it does, because x squared is like a. If we place a equal to x and b equal to 1, we get a squared minus b squared here, which is 0, okay, which is the same as this. So we use this formula here, which means x plus 1 times x minus 1 equal to 0. Now, as you can see, there are two parts of the equation, and they are multiplied together. One way to see that this is going to be 0 is that whenever this side or this side are 0, then the product is 0. And this is because it's easy to remember. Why? Because a times 0 is equal to 0 anytime you choose a. Okay? So suppose x is different from 0, or it could be 0 in this case, but pick an x plus 1 is different from 0. What makes x minus 1 equal to 0? So you can solve that one and it will be 1. If we place x equal to 1, this one cancel out and gets 0, and the product is 0. So this is the solution. Check. And then you look at the other side, you place x equal to minus 1, and then this gets equal to 0, and then the other one will not, because it will be minus 2, but the product of minus 2 times 0 is 0, so then it's another solution. Okay, so this is to show, I mean, of course, if you remember from whatever school or whatever, your own study or whatever, there are, for the quadratic equations, there are formulas that you could use. It's nice to remember it, but maybe it gives you nightmares. So let me just, I hope I'm not making a mess here. So, and I'm dealing with quadratic, and then there are more complicated equations. But let's just, to refresh our size, minus b squared. I don't remember it. Minus b. No, I will check it. I will link it in the end of the video. But anyway, so for the quadratic you need the equation, for the cubic, maybe for the quartic, I don't remember, but somewhere there are standard way to deal with this equation. Of course, you can get easily more complicated than that, because think about, for example, e to the x plus 1 equal to 0. Now it's get a bit trickier, because okay, we can, let's say, now we know the trick, right? We move the minus 1 on the other side. E minus x equal to minus 1, okay? By adding and by subtracting minus 1 on both sides. Let me just refresh it here. We do minus 1 and minus 1. Okay, so this is, now we know that we can, visually we can drop this one on the other side by flipping the sign. Okay, just as a tool, as a mnemonic tool. Okay, now how do we go from this equation to x? So we want to find x, right? Now we need to invert, and I think let me pick, because I don't want to go into complex number as of now. So let me pick minus 1. This is plus. For the complex number is trickier, and I need to refresh my complex analysis. So let's keep it simple for today. So log. So how do we go from exponential to x? We go logarithm. We take the natural logarithm of x, both both sides. And then we go x because it's the inverse function, so the base is the same, so that x, and logarithm of 1, as if you remember function logarithm. I mean, we can check it in many ways, but this is the function. It's 1 when it's 0. It's 0. The other way to see that, to prove that this is correct, is that if you do e to the 0, which is the solution, is equal to 1, but this is by definition. Or if you remember that e to the x is the sum of x, and I will go this, I mean, this is boring, but since we did it, why not? This is the definition of e to the x. So if we place e to the 0, we replace 0 everywhere in the expression where the x is, and of course only one term will survive. Why is that? Because when 0 to the 0 is 1, so the first term will survive. All the other will be 0. 1. Okay, so yes, so we can play with equations in many ways. We can think about how to solve them. We don't have to do it now, but the important thing is that remember that usually, there are also trigonometric equation. Let's do one. Let's do a trig equation just to give you a flavor of those ones. Usually those are nasty, but let's keep it simple. I hope I'm not messing that up. Suppose sinus of x plus 1 is equal to 0. Okay. So if you remember, the sinus is a function which is periodic. It's a nice wave. Okay. Oops. Sine waves. Okay. So if it's periodic, as you already can see, this means that this x will have multiple values for which we get 1, right? Think about it. It's periodic. So if that's value is 1, also here will be 1, and then here, and then here, whatever. So there will be multiple solutions. In fact, this is what's it's called. It's not an invertible function, because if you invert it like naively or graphically, you would do it as you remember. You just flip the graph and you do this, and then this is not a nice function because you have for the same value of x the same value of y many times. So this is not it's not well-behaved function in the sense that, and this will turn out useful, if you think about a function as an association between some numbers and other numbers, okay, usually it's well-behaved. There is a technical term that I don't want to put it now. It's well-behaved when all the function has a one-to-one connection. So you can go on back and forth between these numbers and the green numbers. It's less well-behaved is for multiple value of x, you get the same number of y. And this is less well-behaved because if you want to go back from the red to the green, you see that you have many options. So which one you choose? It's not uniquely defined. Okay, sinusoid is this case here, as many others, but there is a workaround. You just focus on part, let's say a period, section of the function that we will take, for example, this part here, a period of function, and usually it's 0 from 0 to 2 pi in this case. So from 0 to 2 pi, you see that there is only one value that gets 1, so we can solve this, and we know what it is. So it's pi over half. There are many ways to do that. You can look at the graph, you can solve the equation, you remember it. So pi, if your x is pi over half, but again I did the same. I want to take the minus sign here, sorry, otherwise I need to do minus pi half, but anyway, it doesn't matter. So plus half, because now so that's the solution between 0 and 2 pi. But what is the full solution in all the real axis x? You need to add the periodicity, which is plus 2 pi k, where k is whatever number you choose. Okay, 2 pi, because every 2 pi you get the same value. Okay, so this is just a k is a natural number, so it could be 1, 2, 3. Actually, it's not a natural number, it's a relative number. There could be also -1, -2, -3, -4. I mean, you can count it, but you can count it also with negative sign. It could be 0. Okay, so yes, nice. So just enough for equation like with numbers. Let's do a step forward. Before dealing with differential equation, I want to do a matrix equation very briefly. There is a lot to say about equation and matrix equation, but at the moment we don't need it. You see the time? Okay, let me pause the video, otherwise it will take ages to load. And then I will do matrix equation in the next video. So see you soon. See you later.